Question 34. Which statements are correct? Okay, let's have a look at this. This is NH3 reacting with chlorine, giving you nitrogen gas as well as this salt called ammonium chloride. As you know, ammonium chloride, NH4 plus Cl minus, it's got an ionic bond between the oppositely charged ions, but within the NH4 plus, you also have the normal covalent bond, and then one of the bond is a special dative covalent bond, as the nitrogen donates both its electrons in this covalent bond to pick up a H plus, which has no electron whatsoever. Now this is about oxidation and reduction chemistry for option 1 and 2. Option 3 is more about acid-base chemistry. I can tell you number 3 is definitely correct because we could see not just in forming the N2, but the NH3 has formed the NH4 plus. So the NH3 going to NH4 plus, meaning to say you must have gained H plus in order for you to form the NH4 plus. Therefore, what we can say is the NH3 accepts H plus. The NH3 is a base because a base accepts proton. Number 3 is definitely correct there. What else can I say? Well, if number 3 is correct, I should really check number 2 first, to be honest. Each chlorine atom is reduced. So we only have chlorine here, chlorine 0 as an element. We look at Cl2. And then we have NH4Cl, which can be comprised of NH4 plus and Cl minus. So when I look at Cl minus, the oxidation number of an ion is the charge on the ion. So there's Cl minus 1. So for each of these chlorine 0, they don't go and form something else. They just go to form chlorine minus 1. This is a decrease in oxidation number. This is what you call reduction. So each of the chlorine atom is indeed reduced there. Oops, sorry. Each nitrogen atom is oxidized. Well, we have to explore this. This is NH3. If we just look at NH3 on its own, the nitrogen is what we want to find. There's 3 hydrogens. Hydrogen in a compound has a +1 oxidation number, especially when the nitrogen is more electronegative than the hydrogen. So nitrogen is -3. Nitrogen -3 in ammonia. Then you have nitrogen 0 in nitrogen molecule. And you got NH4 plus, that is a +1 for the charge of the ions. There's the oxidation number of the ions. You got nitrogen, you got 4 times +1 for the 4 times hydrogen. Nitrogen is +1 minus 4, nitrogen is -3 there. So altogether, what can I say? The nitrogen -3 doesn't change in forming the salt because this is not a redox reaction. The NH3 plus the NH4 plus is never going to be a redox reaction. Instead, that is simply your acid-base reaction there. It's not a redox reaction as I've shown you there. That's why there are no changes in oxidation number in forming the NH4Cl. But the nitrogen -3 going to nitrogen 0 is an increase in oxidation number. So that is indeed oxidation. But what is wrong with this sentence is each. Okay, each is wrong because some nitrogen remains nitrogen -3. That means not oxidized. Not oxidized at all. So be very careful about what we are saying. Okay. Perhaps I can just move that a little bit there because looks like I'm running out of space. Okay, so in fact number 1 is definitely wrong because not all the nitrogen gets oxidized to form nitrogen 0 in the N2 molecule. Some of them remains unoxidized after all. So 2 and 3 are correct. That's going to be 2 and 3, option C there. Question 25, not 25, question 35, calcium and strontium compounds. These are group 2 chemistry. Looking at option number 2, we're talking about the solubility of the group 2 hydroxide, something you have to relate to group 2 hydroxide solubility. As the radius of the cation increase going down to group 2, things like barium hydroxide is very soluble. And that is the very reason why barium hydroxide has a very high pH of around 14, whereas things like magnesium hydroxide, when MgO dissolve in water, not very soluble, only around pH 9. MgO give you a pH 9 for this solution of magnesium hydroxide in solution. Calcium hydroxide and strontium hydroxide. Where is calcium and where is strontium? So strontium hydroxide will be more soluble than calcium hydroxide as it is below and also lower than calcium in the periodic table. So calcium hydroxide is more soluble than strontium hydroxide. That is already wrong. If number 2 is wrong, there can only be one answer, which is number 1 there. And we know all the group 2 oxides, they are going to be alkaline in solution. So group 2 oxide, well, M2 plus O2 minus. If I just write a generalization, that will give me MOH twice, M2 plus OH minus, as you know how to balance equation. Okay. In terms of the sulfate, we know that the sulfate follow the opposite trend, as you know about the test for sulfate. Barium sulfate is going to be a white precipitate. Magnesium sulfate is slightly soluble in water, so not very soluble in water at all, but we know that solubility of sulfate will decrease down the group. So calcium is above strontium, so calcium sulfate will be more soluble than strontium sulfate, so less is wrong. But of course, in a real exam, if I check number two I'm sure is wrong. That means I only have one answer, which is only one is correct. Question 36, which description of the ammonium ions are correct? So it has a bond angle of 109.5. This is related to what I did previously. When we have ammonia molecule, so we have a trigonal pyramidal molecule. There is ammonia. So 3 bond pair and 1 lone pair, trigonal pyramidal, 107 degree. And when you add a H plus, you're going to form a dative covalent bond. A dative covalent bond is a single covalent bond, and it counts as a sigma bond. And now you have 4 bond pair and 0 lone pair, having used the last remaining lone pair to form a dative covalent bond. When the 4 bond pair repel equally, you're going to get a tetrahedral shape, and that is going to be 109.5 degree there, just like CH4. So number 2 is correct. It contains 10 electrons. Well, in order to say, they don't say about valence electron. If you look at NH4 plus, it would have 7 protons. So let's count the proton first. The proton will be 7 plus 4, which is 11. 11 protons, be very careful. But then you have a -1 charge. So 11 minus 1, you have 10 electrons. So 10 electrons is correct in this ion. Now, it has only 3 bond pair of electron. That is wrong. The very reason why you have 109.5 degree is because of the 4 bond pair and 0 lone pair, having used the last remaining lone pair to form a dative covalent bond, sigma covalent bond, sigma, sigma, and sigma, 4 sigma, 4 bonding pair of electrons, repel equally in the absence of lone pair, tetrahedral geometry, 109.5, 1 and 2, that's option B there. Question 37. So we get compound Q by adding H2O across a double bond. As you know, you're doing electrophilic addition. This is not a normal H2O. This has to be steam, and it has to be done in the presence of like H3PO4 catalyst, and it has to be done at very high temperature as well, 300 degrees Celsius. So which statement about these 2 compounds are correct? Q contains 2 chiral center. I can spot my first chiral center there. If I have my mirror plane there, in the middle there, so this side has a branch there, this side doesn't have a branch, CH3 there, so these and these are different, these and these are different, so I have 4 different groups on this carbon there. If I then see another group here, so the pink color one now, so it depends on where are you. If you are at this carbon, this right hand side is different from this left hand side of this bisecting plane, this pink color bisecting plane. You have a hydrogen which is not shown because carbon for 4 bonds, you don't show the hydrogen bonded to the carbon. So 1, 2, 3 different groups, and there's a hydrogen, so 2 chiral carbon there. So Q contains 2 chiral center, that's correct. P shows cis-trans isomerism. The thing about cyclohexene is that you have a double bond inside a 6-membered ring. So double bond inside a 6-membered ring cannot form cis and trans, so therefore no cis and trans. Okay, so they cannot twist around easily, they cannot twist around for the trans, and therefore there is no cis and trans. So it does not show cis and trans. 1 is wrong, 2 and 3 are correct. That must be option C. In fact, as we know, Q must be tertiary alcohol, as this carbon that I'm highlighting, the black colored carbon, the carbon bonded to the OH is bonded to 1, 2, and 3 other carbon. Tertiary alcohol is definitely correct there. Okay, I guess the trick there really is understanding and also knowing that in a 6-membered ring, you can't have a cis and trans double bond. In fact, they will always be imposed in such a way that they are cis like that. Question 38. we have an organic compound. This organic compound gives a precipitate with aqueous silver nitrate. Typically, this means Ag plus X minus. X minus being your halide ions, because this is the test for halide ions, even from your GCSE, IGCSE, or O-level chemistry. So some or all of these precipitate remain undissolved when you add dilute aqueous ammonia. Very important that it is dilute and not concentrated. So some of all remain undissolved. So we know that AgCl would dissolve in excess ammonia in this equilibrium. In fact, that is how you get Tollens reagent. So 2 of the ammonia plus, let me just write the equation at the bottom so that we don't get confused. So that will happen. That is the solid dissolving in the excess ammonia. You get this aqueous solution, which is colorless solution, what you use in Tollens reagent. Now what happened there is, it says some or all of the precipitate remain undissolved when you use excess dilute aqueous ammonia. AgCl will do that when you use excess dilute ammonia. So it means that the only one, let me think. If I have 2-chlorobutane, so all of it will dissolve. So that means cannot be 2-chlorobutane because all of this will dissolve, because all of AgCl solid would dissolve. They will go away, whereas it says some or all remain undissolved. It doesn't dissolve away. That means some or all of them cannot be the AgCl. If one cannot be the answer, it could be 2 and 3, which is option C. Okay, so we know that silver bromide can only dissolve when you have excess concentrated aqueous ammonia. However, when you use a huge amount of these dilute aqueous ammonia, some of AgBr could dissolve, but definitely not the AgI. Okay. Question 39. Which compounds on heating with excess concentrated sulfuric acid? So this is a dehydrating agent, as you are doing elimination of water. So the type of reaction is not dehydration. Type of reaction is stated in the introductory organic chemistry. You are doing elimination of water. You want to produce only one product with this molecular formula. So the fact that you have 2 OH and there is no oxygen in here, that means we must remove both the water. That is the first thing I noticed. You must remove both the water molecule. Well, I mean, you're going to remove water, right? H2O, because you're going to remove the H from the next carbon. So this thing here have no choice. So I would have, if I go through one first, usually I'll go through 2, but I could see that this one has no choice. And I could very conveniently see that this is symmetrical by the center. So going to this right-hand side H is the same as going to this left-hand side H. I'm going to show you why they are the same, and hopefully you can see why they are the same. So that thing there will be the same as when I go to the left hand side. I remove these 2 H and OH, so I get a double bond there, and I still get my double bond at the bottom. These and these are the same because you can just flip this molecule around and you will get that. So these 2 are the same, so meaning to say I only get one product with this molecular formula where I remove above the H2O. On to the next one. So this H at the bottom has no choice, and then there is only one hydrogen here, and I have to use it with this one because they say C7H10, no oxygen. I have to remove this OH, therefore I have to use this H. If I use this H and I form a double bond there, carbon form 4 bond, 1, 2, 3, there is only one hydrogen there. So after I use this hydrogen for this elimination, there is no more hydrogen for this, but I could need to go to the other hydrogen, which is on this side. So what I'm going to get is, I will get this other hydrogen on the other side, which means I'll get double bond at the bottom there, and I'll get a double bond there, and there is no other product because this thing has to go with this. If this one has no choice on this hydrogen, I have to go with this. There's only one product that will be formed that has these 2 alkene, C7H10 there. Moving on to the next questions, the next option really. So this one has no choice, so I'll just do that. And then I have a choice now. If you see down the mirror plane here, in the center, this side has this thing that has OH, this side has no OH there. So removing from this H on the next carbon, will be different. It will be different from removing. I should probably choose a different color to make my point. Let me choose red, for instance. So removing from this red color is different from removing from the black color, and you can see the two different products. So this is the double bond there, like that, and then the black color one will give me a double bond at the bottom, but then I'll get a double bond there. Hang on, nope, I will not get a double bond there. I will get my double bond here instead, okay, because this double bond is formed there. So that and that is two different products. These are different. So you get two different alkene there, which have C7H10, and you cannot have cis and trans when you have a cyclohexene, and therefore you just have two different products instead of having the cis and trans, etc., etc. Okay. Oops, sorry. I mean I cannot have 3 as the answer because they are looking for only one product, like that. So only 1 and 2 are correct. There must be option B there. Now we've reached to the end of this paper. This is question 40, the last question. So compound Z is heated with concentrated acidified CmNO4. So this is your dark purple color solution. And when you use this acidified, very strong oxidizing agent, what we have really is oxidation of alkene, as stated in the alkene syllabus. So this produces an equimolar mixture of CO2. Oh my god, this one look really long. A bit scary, but let's just draw it out as structural. Sorry, we're going to convert the structural to skeletal. So CH3CO follow here, and then CH2, CH2, CH, and then I will leave the bracket thing later on, CH2COOH. So this is a CO2H, this is a CH2, and then this is your CH. I need to connect the ketone. So there is the ketone and then CH3. This is the CH, carbon from 4 bond, 1, 2, 3. There's a hydrogen there, COCH3, CH2, CH2, COCH3 there. Okay. What do they want? I could stitch back the CO2 and that, but what I think would be quite nice is I just fragment up the molecule. I'll start with number 2 because we always check number 2 first. This side is a CH2 double bond that will give you CO2. That one is a given, okay? Now we look at the other part of the molecule. This one will give you ketone. That one will give you ketones. And then the other side will give you a carboxylic acid. So I've got 2 ketones and I've got to number my carbons. So if this is 1, 2, nope. From the carboxylic acid is important carbon, 1, 2, 3, 4, 5, 6, 7. So I'm going to number my carboxylic acid as number 1 there. So number 1, 2, 3, and then 4, 5, 6, 7. The ketone is at position 6. The ketone is at position 6. At position 3, I have a COCH3. At position 3, I have a COCH3. I also have CO2 from the other part of the CH2 getting cleaved off. Number 2 is definitely correct. If number 2 is correct, I have to check for number 1 and number 3, right? Okay, let's check number 1 first. If number 1 there, that will give you my CO2. And then I'm going to draw what happened to the other part of the molecule. So that thing there will give me a ketone. This is a RC double bond R. This will give me a ketone as well. But then this bit here, this is a RCH double bond that will give me a carboxylic acid. So RCH double bond give you or oxidize to carboxylic acid. So what do I get? So that thing here is here, but this thing here is here. There will be a carboxylic acid. So again, the carboxylic acid, I'm going to number 1 there. So number 1, the carboxylic acid, 2, 3, 4, 5, 6, 7. I have a ketones, C double bond O at carbon 6. I have a COCH3 at carbon 3, COCH3. I have a CO2 from the other terminal carbon, the terminal alkene here, CH2 double bond, which will give me, or oxidize to give me CO2. Number 1 is definitely correct there. Last but not least, let's go through this weird looking structure. This thing here, CH2 double bond, will give me a CO2, no problem. This one will give me a ketone. This one here will give me a ketone. And then the one on the far left, this one will give me a carboxylic acid. There's a hydrogen there. So this one will give me carboxylic acid. So let's draw. So that thing give me a carboxylic acid. That thing give me a ketone. That thing give me a ketone. And I get a CO2. I'm also going to number my carboxylic acid the number 1, 2, 3, 4, 5, 6, 7. Looks weird, but again, I have my carboxylic acid carbon 1, carbon 3 COCH3, COCH3, carbon 6 has a carbonyl, and then I have a CO2. So it looks like number 3 could also give me the exact same product as stated in the question. So 1, 2, and 3 are correct. That's option A there. Okay. We reached the end of this paper 1-2 for the November 2015 Cambridge International A-Levels. Most of the contents we did are applicable to any 16 to 18 years old curriculum around the world. I hope they have been useful. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. There's at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. And a lot of these full paper tutorials are only accessible to silver tier members. So for the price of a cup of a coffee, thank you for supporting my work. You can upgrade to silver tier depending on where you are. And if you can't see any options, you can always use a virtual private network. That is your VPN to upgrade to that silver tier membership and enjoy all these yearly full paper tutorials that I have on my channel. Thank you for watching. I'll see you in the next tutorial video.